Hi, everybody. This is Mark Schaefer. I'm the project manager with iNEMI for the Eco-Impact Estimator Phase 3 project. This is our end of project report out or project closeout review. Thank you for joining us today. We are joined by Tom Okersinski from Nokia, who is project leader, and Zuda Lin from Purdue, who works with Fuzhou, and they have been instrumental in getting this tool ported over to Purdue. So they're both going to talk a little bit about both the tool and the security and how it works. And hopefully you guys will come up with some good questions for us. I do want to let everybody know that you are on mute. We're going to let Tom go through the presentation. He'll then demo the tool. Zuda will talk a little bit about security, and then I'll open it up for questions. I would ask that if you do have a question, you please type it into the chat window, or use the raised hand function when we get to the end of their presentation. I'll ask folks to raise their hand, and I can unmute you so you can ask your question. And we'll just sort of see. It kind of will depend on how many questions we have. If we have lots and lots of questions, I'll probably just have to run that through the chat, and I'll ask the questions for you just to manage the time that we have left, because we do have an hour dedicated to this, and you're not here to hear me, so let me turn it over to Tom and to Zuda. Thanks.
Okay, thank you, Mark, and hello everyone today. We are giving this closeout review for this project, which is the Eco-Impact Estimator, or EIE for short. This is the Phase 3 level of work we've done for this. If some of you have been aware, over many years we have been working on having this Eco-Impact Estimator developed within iNEMI, and this goes back starting over 10 years ago with phase 1 of the project, when we developed the methodology, came up with the first tool, which was an Excel-based tool, then modified and updated the data sets. Well, phase 3 here is a further update of those data sets, and also the development and issuance of the database-driven tool, which is on the Purdue server. So we'll be talking about all of that today. I am co-leader. My name is Tom Okersinski. I'm with Nokia Bell Labs, and along with Dr. Fuzhou from Purdue University, we led this phase 3 effort. You can see the other participants, the primary participants that started out on this project with IBM, Lisa Dender, Erko Helman from TTM, Donald Klein from Intel, along with Alicia Peterson, and then Zuda Lin, who did from Purdue University much of the programming, or most of the program, I should say, for getting that into the Purdue server there and all set up. Project Padraig Murphy with Logitech, and finally Mark Schaefer. Last but not least, Mark has done an incredible amount of work on organizing this and keeping this project going, is with iNEMI. Let me start out going over first what was the project scope and the goals of this phase 3 project. Essentially, as I had mentioned earlier, it was to improve on the original Eco-Impact Estimator tool that we had developed in phase 1 and improved on in phase 2. We wanted to look at the existing component data sets, the methods for estimating the eco-impact, specifically for ICT products. The project goals were to allow targeted users within iNEMI general access to the product evaluations and the case studies, and can provide input and maintain within the tool a secure and accessible means of getting into the database portion of the tool, and for protecting product information and the results in there. And we think we've achieved that and developed that. Along the way, we also wanted to improve the component data sets and our methods for estimating eco-impact of ICT products, and look at in particular whether the eco-impact which is already in there for global warming potential, if we could expand that and include impacts associated with energy usage and water depletion potential. So we wanted to see if we can add that or at least evaluate it. And of course, focusing on our component categories that we had already in the tool, specifically the areas of the printed wiring boards, the integrated circuits, power supplies, cable assemblies, the cooling systems, of course, mechanical parts, both metallic and polymeric or plastic, and concerning passive components relative to active components, and also the packaging materials. Okay, so we have another participant. Hi, welcome. All right, next slide here. So a little bit about LCA estimation, the methods and the goals we had here. Eco-Impact Assessment for ICT products, we've chosen to look at the way in which we look at classes of products and component categories. Most parts have common applications across the ICT industry, and we did that in grouping those in having common component characteristics and criteria and their relative impact to the environment. And our approach here was to take this assessment method as it poses a simplified approach or process to more easily derive eco-impact information. Look at the categorized targeted components that produce the dominant eco-impact and work to get improved data sets there, providing a reasonable level of accuracy that's suited to our industry and our product types. And of course, we wanted to show continuous improvement, this being phase 3, trying to enhance the data sets we had, collect better primary and secondary data around those component sets that we've chosen. So the LCA estimation methodology of common component characterization has been around for a number of years. And indeed, in the past, iNEMI was instrumental in working with the greenhouse gas protocol and in getting this standardized. And indeed, the GHG protocol, which is the term built on the GHGP, we've worked with them to write the ICT sector guidance. And in there, in Chapter 5, is the ICT hardware, and in particular, common component characterization is one of the methodologies defined and described in there in that standard. And you can go to that link at the bottom of the page to see that in particular with the details written in there. And you see on the left the typical component categories that we do have included in the tool, from printed wiring boards and integrated circuits to metal and plastic parts, cooling systems, cables, and product packaging. One of the things that we learned earlier on in common component characterization is that when you look at a product, in this case, this is a mobile network radio unit, and you do the analysis on these component types shown on the horizontal axis there, you see that most of the eco-impact occurs with the active components, and in particular, the integrated circuits. In this case, 62.5% of the total eco-impact to make this radio unit occurs in making the chips. And then you see what the contribution is for the discrete semiconductors, power amplifiers in that case, some of the other microwave circuit components. And you also see the passive components, which are the blue vertical lines, and in particular, the printed wiring board, just the bare board with all the interlayers of copper foil and all the buried vias, et cetera, takes just about a little over 11%. So all of those passive component types, more to the right of this chart, the connectors, the spacers, the O-rings, the chip resistors and capacitors, the inductors, fasteners, and some of the passive frequency control all have very, very small contributions to the total. So early on, we've tried to provide a factor to account for that rather than go through trying to list and account for every one of those components by manually inputting them. This would save a lot of time in doing a life cycle assessment. And indeed, we came up with estimation techniques for these passive components with the data we had at hand. When you look at the total manufacturing stage, again, remember the four main stages of a life cycle assessment. Manufacturing stage, inclusive with all what it takes to mine those materials, manufacture intermediate materials, then final component assembly, and then you take those components and on an assembly line, surface mount or through hole combination, you are doing a circuit pack assembly process. And you are then testing that circuit pack assembly, putting software and firmware on there, and then finally packaging that product and getting it ready for shipment. If you look at all of those processes, we found the most important ones that we go after and measure are the ones in the yellow with the red text and the light blue with the dark blue lettered boxes. We provide factors for to account for those relative to those yellow boxes, the processes going on in them. So those estimation techniques for that further simplify assessing the life cycle impact for the manufacturing stage. When you get to the next stage, which is distribution, we look at factors such as where was that final product assembled, what region, how did you get it to the finish point where you're installing it, where the intermediate nodal points like warehouses, systems integration centers, etc. Also, the final point of installation, you want to know because there then it will be using power for operation. And so you need to know that final product installation point. And then as well as what was the transportation mode, was it surface, air, and other factors pertaining to the transport mode providing for the global warming potential in this case, which is what we're measuring. Similarly, for the use stage, we're looking at the point in which it's installed. So what energy mix is there? The electricity consumption profile for the product, how much active versus idle or sleep mode it's doing. What is the lifespan of the product in years? Are there a maintenance period where the product is down for a good portion of the time, where it's not being used throughout the day? For instance, like a laptop or a desktop may have points where it's not turned on at all, versus an optical switch in a network is pretty much running 365 days a year. And then end of life, the last stage in a life cycle assessment, we wanted to make sure we captured all the constituent materials and then looking at what is the end of life scenario for that. Is it full recycling? Are there materials that are incinerated with energy recovery just to get at the metals? And are some materials inadvertently getting into the landfills? So that mode had to be taken into account when we did our life cycle assessment as well. And again, the project activities themselves, we wanted to look at making the database-driven tool, hosting it at Purdue University on a secure server, having it open for iNEMI access and usage, but still have firewall protection and security so that any company can have and store their information in there and their product information, but not have it being able to be seen by any other user, only those within the company. Updating the data sets for all major component categories, as I mentioned, and those life cycle stage impacts that I mentioned. We did look at global warming potential advancements, some of the data sets available for that. We looked also at other eco impacts, energy use and water resource depletion. In particular, we wanted water resource depletion because many of our customers want to know that besides global warming potential. However, one of the things we did come into early on is a lack of maturity in the data sets in all of our component categories that we have in the tool. So we gathered a lot of data for water resource depletion. We have it, but we didn't have a complete mature set to include in the tool at this time. So it's there, and as we improve on the tool in the fourth phase down the road, we can add the water resource depletion as a full mature element in the eco-impact estimation. Similarly, we've always had an Excel formatted spreadsheet tool. It started out that way. We've introduced the database-driven tool, which we'll demonstrate today. But we also felt that we would keep the Excel format tool and improve on it with the data sets that we had because it had certain advantages still over the database-driven tool. And I'll get into those in more detail. For example, the what-if scenarios turns out to be easier to perform on the Excel tool than it is on the database formatted tool. So we have both tools available for iNEMI members. What did we do as far as the data sets? We were able to capture primary and secondary data in many of our component categories. In this case, the bare printed wiring boards, we're able to get data for both conventional construct and high density interface or HDI. Here in this example, you can see all of the different processes for making those inner layers, the equipment needed to run those processes, and the associated information, the amount of power it takes, the water it takes, and then convert that, in this case, to greenhouse gas emissions in the form of global warming potential and report that in here with the data sets in the tool. All of this we've published almost 2 years ago at the CARES conference. We published a paper on the findings that we had in here and the data sets to make that available publicly, but now that's incorporated in the tool's data sets. Likewise, in the integrated circuits, that being a huge contributor to global warming, as you saw on that earlier slide in impacts associated with a product, we wanted to continue to gather the data it takes to make the silicon, the die in the various technology nodes. As you see here, this is just an example of the energy it takes in all the different process steps for doing silicon in various technology nodes here ranging from 130 nanometers down to 32. We've even got data down to 7 nanometer in some of the newest technologies as well. And we've plotted this with various package types and doing it with lead counts because package type and lead count is what a designer knows and what he's picking and choosing from. So the data interpretation in there is looking at that from primary and secondary data sources from our suppliers and plotting that out accordingly and getting the right algorithms then into the tools. Here's a screenshot of the database tool, and I'll demonstrate this, but just briefly, the light blue bar on the left shows the product hierarchy, so you can build and construct that, starting out with maybe your basic frame or your chassis, then getting into your different circuit packs that slide into your chassis, and then you can do the breakdown of the bill of material for each circuit pack, whether it's starting with the bare printed wiring board and then listing each individual integrated circuit that you're using on that circuit pack. You input the data, and the list on the lower right in the light gray, dark gray line listing then gives you the input, and then you see the output or the associated global warming potential for each of those component types. So it's additive. You build this up in a stack formation. You can add and delete components. You work from your BOM. You're basically putting in your active components, such as your printed wiring board, your ICs, your large plastic or metallic components like a bracket, a structural frame, a chassis, a cabinet, any cabling, etc., even packaging you can add in here. It additively combines that and then gives you in the center here the total CO2 emissions associated with this level of equipment that you've modeled in the tool. And you can use this for other configurations that you want if a product can be highly configured, or you can build it for just one product type that you're marketing, et cetera. And now you have the global warming potential, or what we would say carbon footprint for that particular product configuration or product type. We can do beyond manufacturing stage. We can do all the life cycle stages. So what I showed you on the previous chart was just for manufacturing that product and all the steps of getting those materials, intermediate processes, final product manufacturing, all that combined together. Now we can go and look at the distribution stage, the life usage stage, and the end of life. And we can model that and pick the energy use profiles, the point of destination where the product is installed, and then also do an assessment of end of life, whether it's an actual data that you know you're dealing with so much to recycle content, so much to landfill, so much to incineration, or you're estimating that. The tool can allow you to see what those impacts will be, and then you get the full life cycle then of the global warming potential, and then the breakdown is shown here in this pie chart of what of each of those stages reflects the amount for that full life cycle. Similarly, for the Excel-based tool, we've done that as well. These are screenshots from that. You see in the upper part of this chart lists the active components in there, and all the way down from PWB, Bear, and its passive components down to product packaging. In the modeling, you see the associated global warming potential for these component categories. It gives you the total manufacturing carbon footprint, and then you see the remaining LCA stages: distribution, use, and end of life. And finally, for all stages, in this case, what we've modeled gives us the product carbon footprint there, here showing 488.6 kilograms of CO2 equivalents. And then you can see a pie chart breakdown in the upper right and a bar chart breakdown for manufacturing only to see where maybe your hotspots are. So you can see that the bare printed wiring boards, the cabinet, and the cooling system, just the way this was modeled in this example, would have the highest impacts. If you wanted to go in there and then look at that, you can address what materials and components particularly contributed to the high level of eco impacts, and then study ways in which you can reduce that. So this is a tool. Not only does it give you the product carbon footprint, but then you can focus in on where that carbon footprint emanates from and how you can then do what if scenarios to see if you can try to reduce that. And here's an example further in the Excel tool where we're taking the metallic components, and in this case, the aluminum sheet metal, and looking at that particular line item that we've entered, just as an example, and saying, well, what is the relative eco impact of aluminum sheet mix with 65% recycled content, one of the many materials you can pick in the list, and it tells you an eco-impact level, that little red bar to the left, relative to the lowest material you can pick as a metal in the table. So from that, you can get a sense where your impacts are in a relative level, and then pick and choose if you wanted to pick an alternative material, how much would it lower that by and improve on the overall eco-impact of the product. That's just one example there. So the differences between the database tool and the Excel tool, very briefly, is the database tool gives you a means to build a hierarchy. It's very good if you have multiple sub-assemblies and you're combining them together. And let's say you even build different configurations for different product types or configurations to your customer. That database tool can have those components interswappable, and you can do that relatively quickly with the database version. And likewise, you can also then control and manage those product entries very nicely in the database with the security built in behind it. On the other hand, the Excel tool gives you the flexibility to look at individual materials and see its relative impact on the environment, and then pick and choose an alternative very quickly, because you can do that with the Excel version and the materials we have built in there. It's also good for doing what if scenarios very quickly. But if you want to do multiple configurations, it has a slight disadvantage there. And also how you save the tool in an Excel format and have it stored securely, etc. The database tool has advantages there over the Excel tool. But we give both so that iNEMI members can choose that how they want to use it accordingly. The next steps, now that we're finishing out this project, what we're going to do is maintain an Eco-Impact Estimator oversight group. Basically, iNEMI members, a select few there that will help to continue looking at evaluations of new data, more contemporary data, and then try to make updates again going to these tools, because we want to continually evaluate, assess, make transparent what our assumptions are, what data we do have in there. And as new processes, new technologies come into play, we'll be needing to update this. So having this oversight group will be very important for us to do that going forward. And then, of course, as I mentioned earlier, looking at additional eco impacts, we want to further address the water resources depletion. We have some data right now, but the maturity is not the same level across all component categories. So that's something we feel we can improve on for the next iteration. And of course, the oversight group will continually assess where we're hosting the tool right now on Purdue University, but will there be a better place to have it in the future? That's something that the EIE oversight group can then take on and address, as well as getting other academia and other industry stakeholders to want to participate and work together in a conglomeration of effort here with iNEMI. So all that combined, I think the oversight group can address. So with that, I'm going to stop the presentation part, but give you a view of the tool itself.
So Tom, there were several questions
Sure.
that we got. You might want to just take a look in the chat window and see if there's things you might want to address now or
Can you
later.
read them out, Mark? I don't have it
Sure.
viewable on mine, but
Yeah,
go ahead.
absolutely. So we have, why don't I read them all because they're somewhat related. One is, did you take advantage of the data in the Argonne GREET model? There's also an ask within the LCIA data set for ICs, what is the geographical representativity of the data? Is it worldwide? Then there's a question on what is the magnitude of GWP score for same product compared to PIA?
Okay.
And let's see, actually got some new questions here. Did we have access to primary data for DRAM and Flash? And if not, would we expect emissions from CMOS to be comparable? for similar
Okay.
process models. How do we plan to update in the future? I think we're getting ready to do that. And have
Yeah.
we considered the abiotic resources depletion as an additional impact category? So a bunch of different things. So lots
Right.
of good questions, some to think about. Maybe you can address them now. If not, then why don't you finish your
I'll
demo? We
tackle
can
some
add
of
them at
them,
the end.
and
Okay.
certainly, clearly, we can do many others. Um, so I think it was the Argonne Reed model you mentioned. Is that it?
It is Argonne GREET, GREET model.
Okay, now that we did not take into account, that's something maybe we can look at and see how it can further enhance or complement what we have. What we have here, this came from the HD Pug studies that were done. In particular, some of our suppliers in China gave us primary data on these processes for both conventional and HDI manufacturing over months of operation of their facilities, so that we were then able to look at the chemical usage and the eco impacts associated with those chemicals, the amount of power it takes, the amount of water it takes. You can see it listed in some of the columns here for each individual process running and producing, a square meter, let's say, of board per layer count. So you can go in and model how many layers you have, the type of construct, how many prepregs you have, how many buried views versus print and etch, et cetera. All this was modeled here. You can see some of the modeling graphs done to the right, examples. We did publish this as well, as I had mentioned earlier. We did work with the PIA group to some extent, with MIT on board with HD Pug here in getting this data and utilizing it. Some of the things PIA did even more that we'd like to incorporate is with some of the uh, screen technology and making, for instance, flat panel TV displays, things like that. We do not have a category here that represents flat panel screen, the screen making itself. I think PIA does have that, something I think we can incorporate in here going in the future. Similarly, batteries would be another one that I would like to include in here as well. With all the technologies coming about now and lithium ion happening, I think this is something we can try to capture and include here. The nice thing about it is these are all modules, and you can build every module and have it separate and distinct and pull it in as the user sees fit. Whether you have it or not, you can add it into the tool and then account for it. So this is something I think we want to advance going forward. And trying to remember if there were any other questions that I missed upon, but we certainly can address, if we don't cover them here today, folks' questions and then respond back and post them on the iNEMI site with getting that. Did I miss any other key ones, Mark? I think there was something about DRAM memory.
Yeah. So did we have access to primary data for DRAM and Flash? And if not, would we expect emissions from CMOS to be
Yeah.
comparable for similar process nodes?
So for those technologies, the way we worked was getting what it took for the die fabrication, all the processes. This is just an example of some of the ones you can see here. Lithography was obviously the hugest one that takes most of the energy and produces the most eco impact. But clearly, we wanted to be all inclusive. So we work this down to a package type and a lead count. And then we also have built in here based upon the die size and whether you're what technology node you are building that die at. And of course, you can do that in an additive fashion. So if you're doing a system on a chip or a stacked die array, you can then account for each of the dies on that SoC and then build that up and then come up with the appropriate eco impact estimate for that, for doing that. So that is inclusive in here in that. And that was primary and secondary data, much of that coming from Intel provided that for us.
Okay, why don't I'll keep monitoring that. Why don't you get into the demo so that people can
Yes.
actually see what the tool looks like, as well as give Zuda a few minutes to talk about the security of the tool.
Right.
And then we'll
So
come back around to questions. As
yes.
best as I can.
When you click on the link to the tool, this is what you will see. It will take you to the Purdue server. You will see iNEMI Eco-Impact Estimator. Welcome. You can log in then once you've created a login for your company. If you don't have a login, you will see please register. If you click on the please register, it will give you a form to submit and send that in. And then Suda Lin, who's also on the call, will be looking to set you up with the login information. So do that if you haven't. If you have and you click on login, it will give you your usual check whether you're a robot or not, and then you can get into the server. Once inside, you're going to see this display. You'll see this where you can check initially for the manufacturing stage, and you can do a search on manufacturing. And of course, you can sort yourself either clicking on a product that you already input. You can do an alphabetical search in here. You can do a product part if you've input product part numbers in there. If you've done it by owner, if you've done it by part type, whether it's a configured product, a finished product, a subassembly, and last but not least, you can do it by last date modified, and you can do it by the latest or the oldest. In this case, I'll go by the last one I've created in here for demonstration today, and then you would just click on view. You now see that hierarchy that I had mentioned in here. Let me just pull this up a little bit, get that shown in here. For the concept product, I created a series of component types, picking the component categories, and then each of these has its own screen for providing input. So you would pull that from your bill of material. You see the first thing listed here is your bare printed wiring board. You can go in and edit it once you've created it. Here you can see the basic information where you would type in your component type, your component number. It's asking if it's a backplane or a circuit pack. Reason for that is what we've done is model the passives. And we base that on data from all of past modeling efforts to see how many passives associated with a certain size printed wiring board. And it can be built in there or you can override that. It's your choice. But having that as either a backplane or not will then reduce the amount of passives associated in the algorithm. So in this case, we're just modeling it as a circuit pack. The board dimension here is given in meters, so it's 20 centimeters by 20 centimeters. The region of fabrication, you pick that from your chart, okay? And then whether it's a conventional construct or HDI buildup, once you do that, you put up the number of layers and the layer types, whether they are print and etch, buried via, the number of prepregs, etc. You also then choose how many units of this. Do you have one or you have duplicate boards like this in your product? Once you do that and you submit, it will then give you, in this case, the carbon footprint. So that 1 unit of that 20 centimeter by 20 centimeter board, 10 layers, was 10.4 kilograms of CO2 equivalents. You can always delete an entry once you have it or add. So in this case, if I wanted to create another component, I can go in and select. If I wanted to pick and choose and say large IC, I can then give it a component number, etc. IC1. You would select the component type. I'm going to pick a plastic ball grid array. I'm going to pick the data type. I'm going to go with UPIT. You have a choice between that or GABI. The UPIT is the much more contemporary data. along with the Intel data. And then I'll just say, I'm just going to pick 100 IO ball grid array, and I have two of these guys identical, but total number of units is 1, and I submit. If you go back, I now have IC1 added to my stack, and you can see at the very bottom, IC1 is contributing 1.2 kilograms to make that plastic ball grid array in there. And likewise, I can have this configuration, build it up. I can create a subassembly and bring in a whole subassembly, or I can pick one from one of my other subassemblies that I have in there. So in that case, if it's something I've created already, I can pull it in. I can also use this entire assembly that I've created under called concept product to duplicate that and give it a different name. So then let's say I'm using this to build another configured product and calling it a slightly different name. I don't have to re-input and reinvent all of this hierarchy. I can duplicate it and rename it. You can also delete this as a product as well, given what you have. And you can even add in an existing product or component, pick any one you've created in the past and bring in that whole subassembly and add it into what I'm creating here. So it gives you the power to add on, configure, and make different types of configurations or different subassembly configurations depending upon what you want to model. Likewise, if I want to look at and create cradle to grave, if I do the cradle to grave search, I'm going to do last modified in this case. I'm going to pick my concept product, and I've actually done ahead of time here, just like a baking show, to demonstrate what I've input in here. So in this case, I've already input the transport distribution, the life usage stage, and the end of life. And if I go to the transport, you can see what I've modeled in here for my concept product. I have an EMS location, in this case in China. Again, you can pick any location. In this case, you can pick how many intermediates before you get to the customer premises. You can do an SIC, in which case you click on and it adds you that extra data field. In this case, it would be a systems integration center. And then you would do the air distance or truck distance or marine distance to get it to and from that SIC, and then on to the distribution hub. If you don't have an SIC, take it out, and then you have your more contemporary EMS to a warehouse to the customer premises. And then here you can just see what I've input. Marine distances from China to North America, USA, Canada, on then to customer premises by truck. And then you can see how much contribution is provided then to CO2 emissions, very small amount. But still, with the amount of weight and the nodal distribution, you can model what you'd like in here. Similarly, if I go to the usage stage, you can put in a usage profile. In this case, it's on for 365 days a year. The operating life is 5 years. It uses 10 watts when it's on. It's on for 24 hours a day. Okay, let's say it's a Wi-Fi unit. Okay, and then you get to see what that profile is once you've modeled it. And then finally going on to end of life, I've taken the weight of these materials, the amount of the PCB, and then did the profile for how much goes for recycling, how much goes for incineration with energy recovery, and how much goes to landfill. So 85, 10, 5 in percentage. And you get an associated CO2 emissions. In this case, it's a negative because of the high recycled content. I'm getting those metals back and getting a credit for that in this case. And then you can go to the final summary and see, yeah, the red indicates most of my impact over a full life cycle is coming from the use phase using power for 5 years, 365 days a year, followed by my manufacturing wedge, which is the lighter blue, and then getting that end of life wedge in there as a credit. The transport wedge, the light yellow or medium yellow wedge in there is very, very small, but there it demonstrates where your eco impacts are over your full life cycle stage. And then you can go back in there and change a material, do whatever you want as a what if. So that is the estimator tool. And very briefly, let me show you the Excel tool. So here you have the same thing in Excel format. You can click on and go right to the printed wiring board input stage. Let's expand that so you see it. And a quick demonstration here. We have one group of this. You can give it a part number, anything you want. I have one PWB. The length was 0.2 meters or 20 centimeters. We'll say 0.3 or 30 centimeters in this case. The construct is HDI. The type is a circuit pack. And under the HDI, then you can give the number of print and etch layers. We'll say 2, buried vias 2, and the build-up layers 3, and then the pre-pregs will say 12. You pick your country where you're fabricating it. I'll pick China, PRC. Here's the estimated passives, 2,771 resistors, chip capacitors. You can go with that. It'll tell you what the impacts are, or you can give it a more accurate count. Say, no, I really have 3,966 passives in there, and it will override that. Oops, sorry. Let's put that in 3,966. The override comes in, and then you see the breakdown of GWP, what it took to make the laminate, the process chemicals, the PWB fabrication, what it took to make those number of passive components, final assembly and test, and the total PWB impact is 24.6 kilograms to make this type of board. Of course, you can always override this and say, no, I've done the modeling for this particular thing. I've derived this with a more accurate number, and you can override and put a number in here for this product type or component type, and it will select and use that instead. So going back, you see it puts it in the summary. If I went to the IC, I would do the same. I can do it by lead count and package type, or I can do it by building up the actual system on a chip here and go in with each die and put in each technology node size and model it accordingly with an SOC if I want to do so, or go back and do it as a package type and a lead count. That's put in there, and it would give you the numbers. Likewise, you can do a breakdown of a cabinet, any metallic component. The nice feature with a metallic component is, as I mentioned here, I can go in and just put a part number, put in a weight. I'll just say 1 kilogram. I can pick it alphabetically, listing all the materials in there, or I can say, no, I want to do it by GWP impact, lowest to highest. And then it will start out with brass with 90% recycled content, having the lowest amount. And to make 1 kilogram of brass with 90% recycled content took 0.54 kilograms. If I wanted to then compare with another material, and I had something, let's say, I'm going to go back in here and pick it alphabetically again by aluminum, die cast, 0 recycled content. It's telling me that I can do better than that the lowest number in this category with recycled content is almost 23% lower. So if I wanted to, I can see where the hot spots are. As I put in my materials, I can focus on those areas, do what if scenarios, and change those materials out and see what the impacts are directly. It's kind of a fun way to look at it, but it's also a very powerful way that we've set it up to do that. I'm going to stop there because I want to let Suda Lin just mention about the server, the security built into it, and a little bit about that, and then we'll take questions. Suda?
Hi everyone. Yeah, this is Sura, a PhD candidate from Purdue University, and I'll have a few minutes to talk through about the security and data backup. So the Eco-Impact Estimator is designed with login system so that any user will not be able to view any data from other users, and password is hashed and secured and stored in the server. So that means even I myself am not able to see what's your password. And besides, we also have a data backup plan. So right now, the whole Eco-Impact Estimator is hosted in Purdue for both the data server and the website server. And for data server, we would back up twice a day. And for web server, we back up daily. And all backup would be kept for at least half a year. And we are able to restore the backup within 1 hour. So that means we will frequently back up, and if necessary, we can restore the backup at any point. And another point related to security is if any user logged in but do not have any action for 5 minutes, the system would automatically log out to prevent data leakage. And so that's the strategy of the security and data backup. Thank you.
Okay. So we've had this now up and running for the last several months. If there are bugs that do come up, we will address them, and Purdue University has agreed to continue to work with this, and we'll be keeping this in there. And as I said, we'll have the team to continue to look at new data sets, new improvements to it, and new ways that we can even add modules. Because as I said, if you're doing creating a new component, you can see the types we've gotten in here. I don't have batteries listed here, and I don't have screens, so whether it be LED screens or screens for monitors or anything like that. This is something that I think we can maybe share down the road and get more data, maybe from Paya, something like that, to add to this and complement what we have in there. It would just be the addition of another module per se. So I will stop there, and Mark, if you want to open it up to questions, we can entertain that.
Yeah, so let me look through the chat here and see. Matilda has a question regarding can you extract the results from the tool to an Excel worksheet?
Not from the database. We don't have that programmed in there, but the Excel tool obviously is in Excel. So you will have it in Excel format, what I've shown here. The results here, what you see in summary form is Excel. We have a document that covers the front end of it, the latest version number, et cetera, where we're at. So you can always go in there and pull that version up to see what version we're in. But this would have an Excel format. The other thing that neither of these tools would do is if you have a bill of material and you have it in a spreadsheet-based output, it won't automatically load in there to pop a bomb in there. You are going to have to input this in and model it, with the theory being you need to know what you're inputting in here. You just don't want to have something automatically dumped in there. So you want to parse through and sort through your PWB, through your ICs, and make sure you're accounting for it and inputting the data and understanding the model. So it's kind of done like that on purpose, but it allows the modeler to then see what they're putting in and understand it.
Okay. Sort of, I think, related to the Oversight group. What is the plan for updating the model in the future? How often how can I get involved in that?
Okay, that's fine. Let me just jump to that slide. So as I said, we're going to have the oversight group set up. We will probably be addressing things, try to do it on a quarterly basis to see what are the issues and what are the new contemporary data sets that we can get our hands on, being able to then look at that and compare it and see if we want to then go ahead and include that new data, integrate it into the tools we have here. So I would say look at it as a goal to do this quarterly going forward to see. And then down the road, determine when we want to take on the next major phase of project, which is gathering the project team, getting the members, the iNEMI members and academia, et cetera, to join together as we did here. And then look at, for instance, water resources depletion. We have data already available in there. As I said, it's built in to some extent, but we're not bringing it forward in the tool yet because we don't feel it's mature in all categories of components. But down the road at some point, we'll probably want to address that and maybe do that.
Okay. So I would add that if you're interested in being part of the oversight group, at this point, please send me an email at iNEMI. So my email is marks, M-A-R-K-S, @inemi.org. And I'll add you to that list as we're figuring out when that team is going to meet and what that team is exactly going to do. And then as Tom alluded to, when we get to the point of doing a major update, that will be a reforming phase 4 of this, and we'll reform a project team to work on that together.
Right. And Mark, the
Yes.
link to the database will be here, and I think you'll have that also on an iNEMI site. But for the spreadsheet itself, people have to contact you.
Yes.
To get a copy.
Right now, if you want the spreadsheet, I don't believe we're going to put that on just directly on the website. I'll have at least a little control over that to make sure it's going to iNEMI members.
Yeah, it's password protected.
Yes, I did put in the chat window the URL for the Purdue database login, and that is where, if you don't have access to the tool already, you can click on the register link there, and that will ask you for a little bit of information, which will go to Zuda and then to me to make sure that you're basically, if you're an iNEMI member, we'll grant you access. If you're not an iNEMI member, then we'll reach out to you and figure out if we're going to do can do a demo with you or ask you to become an iNEMI member, whatever it takes based on what you're interested in. Let's see. So yes, some regular logistics, both the presentation and the recording will be available to everybody that registered. We'll send an email out when that is available. Probably a week or 2 is usually the turnaround time it takes. But as soon as it's available, I will get that out from you. So at this point, we are a little past time, but I will give those that are still hanging out an opportunity. If you do have a question you would like to ask, I would say please use the raised hand function, and I will unmute you and let you ask Tom and Zuda or myself, but they're the experts. I'm just along for the ride. If you've got a question you'd like to ask, use the raised hand function and I'll unmute you so you can ask it.
Yeah, and also the data sets, some of the key data sets we had in here that we published in our paper at the CARE conference, we can get people copies of that if they want to see that as well.
Correct.
Right.
I can share that. It might even already be up on the website.
You have it? Yeah, you're right.
I do have it. Right. It might already be on the website. If not, I'll work to get that up there. So I don't see anybody raising their hand. Oh, nope, here's somebody. So Anders, let me unmute you, and then you can. Well, I'm allowing your mic, so you'll have to mute and unmute yourself. So Anders, if you've got a question, just unmute yourself and ask it, please. So you'll need to unmute yourself, Anders. Maybe not.
Maybe best type it in, Mark.
Or type in the chat window if you're having issues with with that. All right, so we also have another hand up, so let me unmute or allow the mic for Matilda and ask. So you should be able to unmute yourself. There you go.
Yeah, thank you very much for this presentation. Is there also a document where you have a list of your assumptions or your methodology, or also a glossary or anything on this website?
The paper that we published has a whole glossary in there, and also a listing of all of the references as well. You can get that very quickly from that. The tool itself, we do have a segment in there that lists all of the data sets, et cetera, and where we got them from and the date of the data set, et cetera. So we can also look at that. But again, that would be if you want to really get into the gist of it, et cetera, and the details.
Thank you.
Sure.
So Anders, all I can do is open your mic. I can't mute or unmute you. I'm sorry. If you've got a question, type it into the chat window, Anders, and I'll ask it for you.
Yeah. And if folks want to still send you questions, Mark, even after this session, we'd entertain them and try to get back to people with responses.
Okay.
They can't get it in here.
So Anders' question basically is do I need both EIE and PIA?
Okay, so PIA, I think, went in the direction for the members that they had in their group. And like I said, as I remember, they took on things like display technology and address how to model that in more detail. But areas that we integrated data together was like the PWBs and the ICs, things like that. We worked together definitely on bringing that together and sharing that information. We do not incorporate the display data in here yet. I'm not sure exactly why we did, but that's something I can get in touch with the PIA team and see if they want to do that in an update with this. I know I've had conversations with Elsa Olivetti, et cetera, on this way back, but we can raise them again.
Okay. And I just put a note into the chat window if you would like the EGG presentation that Tom referred to, just send me an email so I have your email and I will reply back with it attached until I figure out if it's posted somewhere online. Are there other folks that have questions or comments? If so, please use the raised hand function and I'll open your mic. Interesting. All right, let's look at this question here. So Zuda, this might be a question for you. She's saying, Matilda is saying that she can't register, her email's too long.
Yes, I cannot write my entire email address. Maybe that's, and one of my colleagues tried to, and he has the same problem.
I mean, it's limited in field in the characters.
It seems like, yeah.
Okay, well, that's good to know.
Yep.
Yeah.
Okay.
All right.
I'll leave that to Zuda then.
Okay, then I know this issue, then please register it with any like email or part of the email that we know it is you, and we will send you some email to confirm that. Okay. Yeah,
Sorry,
and if it is better, yeah.
I should send you an email. That's sorry.
Yeah, if it's possible, you can send Tom and Mark and me the email so that we know you apply for that. Yeah, and we will modify the registration page.
Okay.
Yeah, so send me a note and we'll figure out what's going on.
Yeah.
It's not an urgent question. I mean,
yeah, no, well, we are trying to find if there are, like I said, the port to the database is new. And so if there's anything that limits somebody's ability to get in, like being able to register, we do need to find that. So thank you very much.
Thank you.
Yeah, that's the thing.
Are there other anyone else with a comment, question, or running into a problem with the LCA database? Otherwise, we are a few minutes past time, and I will let you all go.
Okay.